Hello and welcome back to Math with Mrs. Becker. This is Pre-Calculus and today we are looking at section 1.2, recursive form of a sequence. Now a sequence is defined, they say recursively, meaning it is a recursive sequence if the first term is given. Okay, so they're going to always tell you what the first term is. And there is a method of determining the nth term by using the terms that precede it. So what that means is we will be given a formula, and you will need the term, sometimes two terms, sometimes even three terms, the terms before to fill into the formula to find out what's next. So let's check this out. It says find the first 5 terms of a given sequence by creating a table. So n is the number of term. Okay, we are trying to find 5 terms. Next, you want to put what the formula is. It is 2u sub n minus 1. Remember this from our little intro? This means to use the previous term. So 2 times the previous term plus 3. That gives you your u sub n. So 1, the first term. Now remember they said the first term will be given to you, and notice that is right here. U sub 1 is 4, so we do not have to make any calculations. That is given. The first term is a 4. The second term, we have to calculate it. So it's 2 times the previous term, which is 4, plus 3. 2 times 4 is 8. 8 plus 3 is 11. So the second term is 11. The third term, I take 2 times the previous term, this time it's 11, plus 3. 2 times 11 is 22. 22 plus 3 is 25. To find the fourth term, it's 2 times the previous term, which was 25. Then you add 3. 2 times 25 is 50. 50 plus 3 is 53. Now to find the fifth term, it's 2 times the previous term, 53. Then you add 3. And again, I'm just using this formula that they gave us. So it's 2 times 53, 106. 106 plus 3 is 109. So the first 5 terms are 4, 11, 25, 53, 109. And you may have noticed this is a little domain indication. It says that n is greater than or equal to 2. What that means is this formula works for the second term and above. Remember that first term has to be given. So that's all that this tells you, is once you get to number 2, like we did the second term, that's when you start using the equation. Okay, let's look at another one. This is kind of fun stuff. So again, they want us to find the first 5 terms by creating a table. So n is the number of terms. Let's check out what our formula is. This time our formula is 1/3 times the previous term. That's what that n minus 1 means. Then u minus 4. And we will go u sub n. The first term in a recursive formula is going to be given to you. So the first term is given. We do not use this formula until term 2 or above. The given term is 5. Now this time, we're going to have to do a little bit more math. We're dealing with fractions. The second term, it's 1/3 times the previous term, which is 5, minus 4. Okay, now let's think of fractions here. When you're multiplying fractions, it's top times top, bottom times bottom. So 5 is the same as 5 over 1. So this would be 5/3 minus 4. But here's another problem. You cannot subtract fractions unless you have a common denominator. So I need to realize that 4 is really 4 over 1. So if I multiply top and bottom by a 3, what I have is 5/3 minus 12 thirds. Remember, when you are subtracting fractions, once you have a common denominator, that just goes all the way over into the solution. What you're subtracting is the top. 5 minus 12 is negative 7. So my second term is negative 7 thirds. Now to find the third term, it's 1/3 times negative 7 thirds minus 4. So again, thinking of our fractions, 1/3 times negative 7 thirds minus 4. When you multiply fractions, it's top times top, bottom times bottom. So 1 times negative 7 is negative 7. 3 times 3 is 9. Minus, now again, I'm subtracting fractions. I need the denominator to be a 9. So I need to multiply top and bottom by 9 so I can change this 4 into a form where I can actually do the math. 1 times 9 gets me a common denominator of 9. 4 times 9 is 36. So my denominator carries over. If you take negative 7 minus 36 more, what we have is negative 43 over 9. Okay, let's go to number 4. So the fourth term, it is 1/3 times the previous term, negative 43 ninths minus 4. So again, we have to do some calculations. So it's 1/3 times negative 43 ninths minus 4. Top times top. If I go ahead and I am checking something, perfect. Okay, so if I go 1 times negative 43, it's negative 43. 3 times 9 is 27 minus, this is 4 over 1. I need this to have a denominator of 27, so I need to multiply top and bottom by 27, so that way the bottom number matches. 4 times 27 is 108. Common denominator is 27, so that's going to be the denominator. Negative 43 minus 108 more is negative 151. Okay, so we have negative 151 over 27. Last but not least, and obviously you guys, they're not all going to be this much work. This one, I wanted to make sure I had a challenging question in the notes. So if you do run into anything during the book assignment that looks familiar, you do have something to refer to, okay? Last one. So to find the fifth term, I take 1/3 times the previous term, negative 151 over 27 minus 4. Okay, so when I do this, I'm going to kind of go up here. 1/3 times negative 151 over 27 minus 4. Top times top, negative 151. 3 times 27 is 81 minus, this is 4 over 1. So I need to multiply top and bottom by 81 to get that common denominator. 4 times 81 is 324. My common denominator stays, it's 81. Negative 151 minus 324 more is negative 475. Okay, so this is my fifth term, negative 475 over 81. So it says that we have to create a table, which we did. Find the first 5 terms. So our first 5 terms are 5, negative 7 thirds, negative 43 ninths, negative 151 27ths, negative 475 81st. There are the first 5 terms of that recursive formula. Okay, now the next one, this is so cool, you guys. So if you look at this formula, it says to take the previous term and then 2 terms before and then 3 terms before. So that's why this says that you cannot use this formula until you get to the first 4 terms. What that tells us is that they have to give us 1, 2, 3. The next one, as we do this table, it's going to be given, 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 because they're giving us 3. The formula, take the previous term plus the term before that plus the term before that. So you take the previous, not only 1 but 2 but 3, you take the previous 3 terms and you add them together to find the next term. The first term is a 1. It is given to you. Your second term is also given to you. The second term equals a -2. The third term is also given to you. The third term is a 3. So now the fourth term, and if you notice, this tells us that we can start using the formula when we're looking for the fourth term. It says to take the 3 prior terms and add them together. So 1 plus -2 plus 3. 1 plus a -2 would be -1. -1 plus 3 is 2. Now to find the fifth term, you have to add the previous 3 terms. So -2 plus 3 plus 2. -2 plus 3 is 1. 1 plus 2 is 3. So here are the first 5 terms. 1, -2, 3, +2, 3. So those are 3. We had 3 really good examples of how recursive formulas work. We use a table, so that way we have a little place to work and see how everything works together. Okay, you use the table, create 5 terms, list your 5 terms for the sequence. Okay, next, they want to give us a sequence and we have to figure out what that formula would be. Okay, basically we're going backwards. The first term here is a -7. Now to find the next term, what happens, okay? I need to kind of look for a pattern. Typically, I like to go ahead and look and see if we're adding or subtracting the same value. Like here, to go from a -7 to a positive or to a -4, I'm adding 3. If I'm going from a -4 to a -1, I'm adding 3. -1 to 2, I'm adding a 3. 2 to 5, I'm 3. So notice what happened is to go from one term to the next, you have to take the previous term and add 3. So it's u sub n minus 1 plus 3. That's what the formula is. They give you the first term. Sorry there, okay? They give you the first term. It is -7. To find the next terms, you take the previous term and you add 3. So to find the second term, -7 plus 3 is -4. To find the third term, -4 plus 3 is -1. We defined the sequence recursively. That's what this is, being able to figure out the formula. Then they want us to graph it. Remember, when you're graphing, the number, the term number, that's the x. That means that this x is a 1 because it's the first term. This x is a 2, this x is a 3, this x is a 4, this x is a 5. The value of the term is the y. This sequence, the first term is -7, the second term is -4, the third term is -1, the fourth term is +2, the fifth term is 5. When we go to graph this, remember you graph it as a scatter plot. What that means is you do not connect any of the points. 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. Okay. When you graph a sequence, you use disconnected dots. Go to the right 1, down 7, there's a point. Go to the right 2, go down 4, there's a point. Go to the right 3, down 1, there's a point. Go to the right 4, up 2, there's a point. Go to the right 5, up 5, there's a point. So notice we have pretty much a line of disconnected dots. Let's look at another one. If you are given the terms, can you figure out what's going on? Okay, I'm even looking at the whole numbers. Well, to go from 1 to 2, I'd add 1. But to go from 2 to 4, I would be adding 2. So my whole adding trick from the last one doesn't work. The value's going up, so I know I'm not subtracting or dividing. So let's check out multiplying. To go from 1 to 2, you'd have to multiply by 2. To go from 2 to 4, you'd have to multiply by 2. So let's check this out. If I take 1/4 times 2, top times top, bottom times bottom, it would be 2/4, which, hey, look at that. It is 1/2. 1/2 times 2. Remember, anytime you multiply by a denominator, the denominator cancels, leaving you a 1. So this time our pattern is to get from one number to the next, you always multiply by 2. My first term is 1/4. To find the nth term, you have to take the previous term times 2. Or you could write it 2 times the previous term. Either way is good to go. You're just saying take the term before, multiply it by a 2. However you want to write it is good. Now what we have to do is go ahead and it says to graph it. My ordered pairs, remember it's what term? So that's a 1, 2, 3, 4, 5. That's what the x is. The y's come from the value of the term itself. The first term is 1/4. The second term is 1/2. The third term is 1. The fourth term is 2. The fifth term is 4. We're going to go ahead and graph it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If I look, all of these values are positive, so I only need to look at quadrant 1. If I go to the right 1, it's only up 1/4. If I go to the right 2, it's up 1/2. If I go to the right 3, it's up 1. If I go to the right 4, it's up to 2. If I go to the right 5, it's up to 4. You don't connect them, but if you were to, notice that it would be a curve because it is multiplying, so it's growing at a curve. Where this one, had we connected it, it would have been a pretty straight line. Okay, let's go ahead and look at the back side. One more where we have to figure out what the pattern is. So again, if I look and I try to add or subtract, -4, to get it to a -8, I'd have to -4. -8, if I -4, that would be a -12. So I can't do subtracting. The values are getting smaller, so it's not adding. But I do notice 4, 8, 16, 32. I can tell that what we're doing is we're multiplying. Like 4 times 2 is 8, and 8 times 2 is 16, and 16 times 2 is 32. And this stayed negative. So what that means is I am multiplying by a positive 2. Because if I would have been multiplying by a negative, negative times a negative would have changed every other term into an opposite. So you would have negative, positive, negative, positive. Okay, so just to make sure we've got this, -4 times 2 is a -8. -8 times 2 is a -16. -16 times 2 is a -32. So we have the pattern. U sub 1, the first term is a -4. U sub n, we take 2 times the previous term. Okay, now again, we have to graph by creating a scatter plot. If I go ahead and look at these as ordered pairs, the first term is -4. The second term is -8. The third term is -16. The fourth term is -32. The fifth term is -64. When I am graphing this, holy smokes, I got to go 1, 2, 3, 4, 5, because I only have to go to 5 terms, but I'm going all the way down to -64. So I'm going to go by tens. -10, 20, 30, 40, 50, 60. Go to the right 1, down 4. Go to the right 2, down 8. Go to the right 3, down 16. Again, you're just doing the best you can. Go to the right 4, down 10, 20, 30, and a little bit more. Go to the right 5, down past here. So again, this is what your graph would look like. I'm just kind of making dots. We don't connect it, but I'm showing you that this is curving downwards because we are multiplying. So as you go to the right, it is getting more and more negative. All you needed to do were to have these dots that went with the ordered pairs from the recursive formula, okay? We have a real-life scenario. When in real life do I have to actually know these sequences, Mrs. Becker? Well, let's look at this. One thing before we start, when you are working with real-life scenarios, your sequence is not always going to start with a 1. Depending on the scenario, you might start at a 0 or maybe even at a 4, okay? So that's just something to keep in mind. You will not always start with a 1. And even notice here, this one we started with a -4, okay? Example, a ball is dropped from a height of 9 feet. it hits the ground and it bounces to a height of 6 feet. And this pattern continues, so it continues to bounce, and on each rebound, it rises 2/3 the height of the previous bounce. Well, notice this. Okay, so it starts at 9. The first bounce is 6 feet. Okay, so U sub 1 is 6 feet, because what we're doing is we're looking at the height on each bounce. So this is the height of the first bounce. Our recursive formula says that on each rebound, it's going to go up to 2/3 the height of the previous bounce. So there is my formula. Okay, create a table and graph showing the height of the ball on each bounce. So again, number. Let's go to the formula. Then we will know the height of the ball. The first one, because it's a recursive formula, this is given to us, it's 6 feet. Now the second one, and I'm going to show you how to do this on your calculator. We would take 2/3 times 6. Okay, the last fraction one we did by hand, this one I'm going to show you how to do in the calculator. Remember, you do have a fraction bar. What you do is you hit the numerator, fraction bar, denominator. So it's 2/3 of, now in parentheses, I'm going to go ahead and put the previous bounce. So 2/3 of 6 is 4. The third bounce, I have to take 2/3 of the previous bounce, which is a 4. So if you're using these calculators, now you just have to up arrow. It's 2/3 times the previous bounce. That's a 4. So it's 2 2/3. Okay, to find the fourth bounce, it's 2/3 times 2 2/3. You can do this in your calculator as well. This is a mixed number. So I have 2/3 times. To do a mixed number, it's the whole number. Fraction bar, that indicates that it's connected. The numerator, fraction bar, denominator. So this on a calculator is what 2 2/3 looks like. We have 1 7/9. To find the fifth bounce, it's 2/3 times 1 7/9. So again, I have 2/3 times. The whole number is a 1. The numerator is a 7. The denominator is a 9. 2/3 of that is 1 5/27. Okay, it says create a table. Here is our sequence: 6 feet, 4 feet, 2 2/3 feet, 1 7/9, 1 5/27. So there's the first 5 bounces. They want us to go ahead and graph it. So I'm going to the right, 1, 2, 3, 4, 5 bounces. The highest I go up is 6. 1, 2, 3, 4, 5, 6. Now when I plot this, my ordered pairs, the first bounce is 6. The second bounce is 4. The third bounce is 2 2/3. The fourth, sorry, I jumped up to the fifth. The fourth bounce is 1 7/9. The fifth bounce is 1 5/27. Again, you're creating a scatter plot. So 1, 6, 2, 4, 3 2 2/3, 4 almost 2, 5 just a little bit over 1. Find the height of the ball in the fourth bounce. Well, here you go. The fourth bounce, the height was 1 7/9 feet. We just had to take that information out of the table. Last example, and then your assignment is to do a worksheet practicing recursive formulas. If the starting salary for a job is $20,000 and a raise of $2,000 is earned at the end of each year of work, what will the salary be at the end of the 6th year? Find a recursive function to represent this problem. Use a table and a graph to find the solution. Okay, so U sub 1. If the starting salary for a job is $20,000 and a raise of $2,000 is earned at the end of each job. So the first year is $20,000. Then after that, it is the previous pay plus $2,000. So your first year is $20,000. At the end of each year of work, you're going to be getting an additional $2,000. So we can go ahead and make a table. N, number of year, and they are asking us to go all the way to 6. we can do that because we're rock stars. 1, 2, 3, 4, 5, 6. Our formula, 20,000. Oh, sorry, that's the first term. Okay, our formula is u sub n minus 1 plus 2,000. My bad. Then from there, we have our u sub n. So our first term is given. Your first year on that job, you're making 20,000. Then it's the previous term, 20,000 plus 2,000. So now it's 22,000. Okay, your third year, it's 22,000 because it's the previous year plus 2,000. So 22,000 plus 2,000 is 24,000. Now it's the previous year, 24,000 plus 2,000. So now we're up to 26,000. Take the previous year, 26,000 plus 2,000. That's 28,000. Your sixth year, it says, what will be the salary by the end of the sixth year? Well, it's 28,000 plus 2,000. So that answer would be 30,000. Okay, so we found a recursive function. You take the previous term and you add 2,000. We created a table to find the sixth year and be able to create that solution. They want us to do a graph. I'm only going to need the first quadrant because here everything is positive, okay? I'm going to go by 5,000s. 5,000, 10,000, 15,000, 20,000, 25,000, 30,000, and that's your pay. This is the year. 1, 2, 3, 4, 5, 6. That's how many years you've been on the job. So the first year, you're getting 20,000. The second year, you get 22. The third year, you get 24. The fourth year, you get 26. The fifth year, you get 28. The sixth year, you get 30. So it's 20,000, 22,000, 24,000, 26,000, 28,000. If they ask you to state the first 5 terms, 1, 2, 3, 4, 5, those would be the 5 terms. This is what it looks like graphically. Here's the table. We answered the question. What would the salary be at the end of the 6th year? It is 30,000. That, my friends, is section 1.2, recursive forms of a sequence. I hope you had a great time. Your assignment is a worksheet, and I'll talk to you soon. Bye.